So we said, remember, this is right triangle stuff, right? No. So if I say sine squared of theta, now this is the weird part. Sine squared plus cosine squared equals 1. One little thing I want to point out. When we say sine squared of theta, this is mathematical notation that really means sine of theta squared. If I put the 2 here, you'll think that it's sine times the angle squared, so mathematicians put the 2 here. In other words, this is like saying sine of theta times sine of theta. Okay, so this is some trig notation. This is not the same as sine of theta squared, because that means sine of theta squared, or sine of whatever the measure of theta is times theta. You got to get that notation right. So this is the thing. Well, what is sine? Well, if we go back and we look at SOHCAHTOA, sine is the opposite over the hypotenuse, isn't it? But we're going to square that. What's cosine? Well, cosine is the adjacent over the hypotenuse. So we're going to square that. And we say that that equals 1. Okay, so when you square that, remember that one of the properties of exponents is that's the same as O squared over H squared, isn't it? And then this becomes A squared, the adjacent squared, over H squared. Remember, all these numbers and stuff, or all these variables, theta, A, O, H, they all represent numerical values. We just don't know what they are yet, right? These are variables. So let me ask you a question. When I say 3/5 plus 2/5, isn't that the same as 5/5, right? Well, where do I get that from? Well, what I do is I say 3 plus 2 all over the common denominator of 5, right? So I'm going to do that over here. Can I say O squared plus A squared is equal to all that over H squared? And then I'll say that's equal to 1. You guys following what I'm doing? Okay. So now watch this. What is O squared plus A squared actually equal? H squared, right? Mr. Adams has been having you write that down for a long time. Where does that come from? The Pythagorean theorem, right? We say that A squared plus B squared equals C squared. That's why it's called the Pythagorean identity. So if this is equal to H squared, can't I write this as, can I plug in for this? O squared plus A squared, right? O squared plus A squared is equal to H squared. So can I write H squared? Can I substitute that in over H squared? Doesn't that equal 1? Anything divided by itself is 1. So that's the identity. Okay, that's the proof of the identity. Now there's two other identities that we could do. And so I'll give you guys a second to write that down. Does everybody have that written down? Yeah? Let's move on to the other two. So now from this original Pythagorean identity, which is sine squared of theta plus cosine squared of theta equals 1. So this is an interesting thing. I could memorize these identities or I can memorize the derivation. This is kind of easy to remember. So this is how Mr. Adams knows the other two. What happens if I subtract? Well, let me back up, not subtract. What happens if I divide everything by cosine squared? Can I do that? Yeah, I could do that. That's a legal move. In algebra, I could do whatever I want to an entire equation as long as I do it to each term in the equation. But remember, we just said that tangent of theta is equal to sine of theta all over cosine of theta. So this first term becomes tangent squared of theta plus, what's cosine squared over cosine squared? 1. What is 1 over cosine squared? Well, we said that secant of theta is equal to 1 over cosine, didn't we? They're reciprocals, right? So then this one becomes secant squared. That's the second Pythagorean identity. So now to find the third Pythagorean identity, I'm going to say sine squared of theta plus cosine squared of theta equals 1. And now I'm going to divide by sine squared for every term. Well, sine squared of theta divided by sine squared of theta, that's just 1. We said that cotangent of theta is equal to cosine of theta over secant, not secant, sine of theta. So this is actually, I don't know why I put the equal sign, cotangent squared of theta. And then we said that cosecant, that's why I said cosecant, of theta is equal to 1 over sine of theta. So then this becomes cosecant squared of theta. Now what's really nice about these, and you guys haven't done the homework on these yet, somewhere in your homework you're going to get one trig function squared. And it's going to ask you to do the identity. And whenever you see a trig function squared, immediately, like an alarm should go off in your brain, Pythagorean identities. Somewhere in your homework, not today, it'll probably be tomorrow or the day after. Somewhere in your homework, you'll see tangent squared or secant squared or cosecant squared or sine squared or cosine squared. Immediately, when you see one of these trig functions squared, immediately go, oh, that's the Pythagorean. Let me look up and see which one works. Okay? So now let's do an example of this. You're looking at me like, we get out at 35, right? All right. So let's do an example of this so you could kind of put it all in there in perspective, okay?